Isentropic versus polytropic process. So today, aaralin natin yung key differences nila na pwedeng lumabas sa board exam. Okay? So first, punta tayo sa concepts. Ang guiding equation pag isentropic is PV raised to K equals C. Pag polytropic naman, PV raised to N equals C. Okay? So tandaan nyo, pag isentropic, palaging K yung ginagamit. Pag polytropic, palaging N. Okay? Etong K, ibig sabihin yan, is specific heat ratio. Ang formula niya is K equals Cp over Cv. Kung hindi kayo pamilyar dito, panoodin yung thermodynamics formulas na lesson ko. So yung K, may value yan. Yung value niya nakadepende kung anong substance. So pwede siyang 1.666 kapag argon, helium, mercury, or neon. Then 1.4 naman kapag air or hydrogen. Also 1.399 kapag nitrogen and carbon monoxide. Etong N ng polytropic, tinatawag natin yan Polytropic Index. So may value din to, pero nakadepende naman sa process. So N is equivalent to infinity kapag isometric process or yung volume natin constant. 0 naman siya kapag isobaric pressure or pressure is constant. And then N equivalent to 1 kapag isothermal process or yung temperature natin constant. Pag N is equivalent to K, tandaan nyo parehas yung N and K, isentropic process or yung entropy natin constant. Then kapag yung N is equivalent to positive or negative, ibig sabihin yan any value, ito ay polytropic process or yung PV raised to N equals C. Then pag isentropic, di ba, from the word itself, yung entropy mo is constant. And therefore, pag change in entropy, 0 lang. Pag polytropic, yung entropy natin not constant. And therefore, yung change in entropy may value. Then also, tandaan nyo pag isentropic, both adiabatic and reversible. So, kailangan dalawa sila. So, adiabatic, ibig sabihin, yung heat mo, 0. So, walang heat transfer. Pag reversible, no friction, and therefore, no losses. Pagdating sa polytropic, yung heat natin can be non-zero. Okay? So, pwedeng may value siya. Also, can be irreversible. So, tandaan nyo mga yon. And then, pag isentropic, pwede natin siyang tawaging ideal process. Bakit? Kasi nga, no friction and therefore, no losses. So, ideal yan kasi wala tayong loss. So, therefore, gagamitin lang siya kapag ideal turbines, compressors, or nozzles. While sa polytropic, non-ideal yan. Bakit? Kasi nga, meron tayong losses and therefore, applicable to sa real-world applications. So, ginagamit siya for real compressors and expansion in cylinders. Then for the formulas, always tayo mag-start sa PV and T. Okay? So first, relationship ng pressure and volume. So basically, parehas sila except K pag isentropic and N for polytropic. Then relationship ng pressure and temperature. So ganito. Okay? So basically, parehas pa rin except dun sa K and N. Then relationship ng volume and temperature. So parehas ulit sila except dun sa K and N. Then for change in internal energy, parehas sila. Also pag change in enthalpy, parehas din sila. Then, pag isentropic, change in entropy 0, and yung heat natin 0. While sa polytropic, we have MCN ln of T2 over T1. Pag heat naman niya, MCN times T sub 2 minus T sub 1. Okay? Etong CN, tinatawag natin yan, polytropic specific heat. Okay? So, aaralin natin mamaya kung ano yan. For the non-flow work, meron tayong ganito. Basically, pares lang sila except dun sa K and N. Okay? So, ba't itong P₂V₂ and P₁V₁ naging MRT2 minus T1? Okay? Tandaan nyo galing yan sa PV, MRT. So, pag change in state, so equivalent na yan sa change in PV, equivalent to MR change in T. So, tandaan nyo, nagpapalit dito or nagbabago is PV and the temperature. So, magiging P₂V₂ minus P₁V₁ equivalent to MR times T sub 2 minus T sub 1. Okay? Kaya naging ganito. Then, for the steady flow work, we have negative change in enthalpy kapag isentropic. Pag polytropic naman, magdadagdag ka lang ng Q. Diba kasi sabi natin, pag isentropic, walang heat. Then for the CN or yung polytropic specific heat, we have two formulas. Then for the diagrams, lagi tayo nag-start sa PV and TS diagram. Okay? Pag PV diagram, yung area under the curve is tinatawag na work done. Okay? So either work done on or work done by the system. Pag TS diagram, yung area under the curve, tinatawag nating heat transfer. Okay? So pwedeng heat added or heat rejected. Now, kung papansinin yung TS diagram ng isentropy, wala tayong area. And therefore, yung heat natin is 0. Okay? Also, mapapansin nyo, vertical lang siya. Bakit? Kasi nga yung entropy natin hindi nagbabago. Mapapansin nyo that yung PV diagram ng isentropy is steeper yung kanyang slope. Okay? Ibig sabihin na yung value ng N parehas ng value ng K. While the polytropic, shallower yung slope niya. So, ibig sabihin nun, yung value ng N less than the value of K. Or pwede rin maging steeper yung kanyang slope. Ibig sabihin nun, yung value ng N mo, mas mataas na sa value ng K. And then for the TS diagram, yun nga nasabi natin, vertical siya, so constant entropy. While yung TS diagram ng polytropic is a curve. Okay? So ibig sabihin, yung S or entropy is not constant and therefore yung Q natin may value. Then for the units, we have English and metric system. So we have pressure, volume, temperature, internal energy, enthalpy, heat, work, entropy, and K, CP, CB, and CN. So dito, ito yung pare-parehas ng units, okay? So let's start. For the pressure, under English, we have PSF or PSIA. Pag metric, we have Pascal, pwedeng kilopascal or megapascal. For the volume, we have cubic feet and cubic meter. For the temperature, we have Rankine and Kelvin. Then for this, we have BTU or Photon force, pwede ring joules or kilojoules. Pag entropy, we have BTU per Rankine and joules per Kelvin. While dito, unitless kasi nga, these are constant.